The volume of water used by the Save the Water company to top up an ornamental pool has been observed to be normally distributed with mean mu equals 175 and standard deviation sigma is 15. The ornamental pool is topped up 50 times. Determine the probability that the sample mean volume will be between 173 and 177. So the sample mean we would expect to be normally distributed with a mean the same as this and a variance of 15 squared divided by 50 because we do it 50 times. So we want the probability that x bar is between 173 and 177. So we need the calculator for that. And we're going to go distribution continuous. It's a normal CDF that we want. And we've got 173 to 177. Sigma is going to be 15 divided by the square root of 50. And the mean is 175. That's okay, that 0.6542. The total volume of water used is less than 8.96 kilolitres. Now remember, so that's 8960 litres, that we filled this 50 times. So 8,960 divided by 50 is 179.2. So we're after the probability that x bar is less than 179.2. So normal CDF again, and the lower we can make that into negative infinity. The upper is 179.2. The sigma once again is 15 divided by the square root of 50, and the mu is 175, and that's 0.9761. Okay, so water is a scarce commodity and accuracy is required. The pool is topped up 50 times and the sample mean obtained is denoted by W bar. If it is required that the probability that W bar is between A and B is 0.99, then determine the values of A and B, each correct to 0.1 litres. In other words, what we want is a 99% confidence interval. So we're after a 99% CI. So what's our Z score for that? So we want an inverse. If we go center 0.99, and we want to leave these as 1 and 0 because it's a Z score, and that is 2.5758. 2.5758. So our confidence interval is going to be the mean, which was 175, take away 2.5758 times the standard deviation, which was 15 over root 50, and then the 175 plus 2.5758 times 15 over root 50. So let's see what that gives us. So we've got 175, take away 2.5758 multiplied by 15 over root 50. That gives us 169.5, and and then we want the same thing, but with just a plus there instead. And that's 180.5 to the required degree of accuracy. So, if the probability for the mean amount of water used differs from mu by less than 5 litres is 96%, find n, the number of waterings that need to be measured. So what we're doing here, reading around this, is a 96% confidence interval. So I can go up here, change that to 0.96, and that gives me that my Z value is 2.0537. And when we have our confidence interval, what we're saying is from the mean, this can go up and down by 5. Well, if we go back here, this is the part that it goes up and down by. So what we've got is 2.0537 times 15, but this time we don't know the n. We want that to be equal to 5. So we can solve that for n. So action advanced solve, and I've got 2.0537 multiplied by 15 over the square root of x is equal to 5. And that gives me that x is 37.9, and a situation where we always round up, so we'd say n is 38. A rival company called Wallyworks takes over the watering of the ornamental pool. Over 36 consecutive days it was observed that Wallyworks company used a total of 6.57 kilolitres. The standard deviation for the 36 days was also 15 litres. A representative from Save the Water states that Wallyworks are using significantly more water than we did when we were filling the pool. They are wasting water. Perform the calculations necessary to comment on this claim. So what I might do here is form a confidence interval for Wallyworks. So 6570 divided by 36. So 6570 divided by 36 is 182.5. That's their mean. Now, if I do a 99% CI, that's going to be 182.5 take away, now the 99% was 2.5758, 2.5758 times, so we're told that their standard deviation was also 15, 36 consecutive days, square root of 36 is 6, and 182.5 plus 2.5758 times 15 over 6. So let's see what that gives us. 182.5 take away 2.5758 times 15 over 6 gives me 176.1, and the top end, not that we really need the top end, but just for completeness, 188.9. And the mean for Save the Water was 175, which is outside this confidence interval. It's over here compared to this confidence interval, and I would say that that adds credibility to the claim for Save the Water. We do have some evidence that Wallyworks are using more